Dear students, today we'll see the remaining questions to be solved in 2019 DCET question paper. So let's start with the first question. The question is symbol X represents dash in Verilog. Now here, Verilog is a hardware description language. Now hardware description language such as this system Verilog uses symbol X to describe any unknown logic value. That is, if a simulator is unable to decide whether the logic value should be logic 1 or logic 0 or Z, like high impedance, then it will assign X to that value. That means if a simulator is unable to decide then any unknown logic value, then it is going to put a symbol X. So symbol X represents unknown logic value. So here option C, that is unknown logic value, will be the right answer. So here you can see symbol X represents unknown logic value. Then we'll go to the next question, question number 82. A construct that is executed only once in the simulation is called dash construct. So a construct which is executed only once in the simulation is the initial construct. So option C is the right answer. Initial construct or initial blocks cause particular instruction to be performed at the beginning of the simulation before any other instructions operate. Initial blocks only operate once. Now, as compared to initial blocks, you can have one more blocks which are called as always block, which can be always executed. Okay, so compared to that, the initial construct is one which will be executed only once in the simulation. These blocks are primarily used to initialize variables and drive design parts with specific values. So here the option C will be the right answer. A construct that is executed only once in the simulation is called initial construct. So here you can see option C is the right answer. Then we'll go to question number 83. A dominant mode of waveguide depends on options are the power level of the signal, the point of the power injection, the shape of the waveguide, and none of this. Now here, among the various modes of propagation in a rectangular waveguide, the mode of propagation which has lowest cutoff frequency or highest wavelength of propagation among the other propagating modes is called as dominant. Now the physical dimensions of a waveguide determine the cutoff frequency for each mode. The physical dimensions of a waveguide will determine the cutoff frequency of each mode. If the frequency of the signal is above the cutoff frequency, then the electromagnetic signal can be transmitted with minimum attenuation. So as a whole, the physical dimensions means the shape of the waveguide. So here, the dominant mode of waveguide depends on the shape of the waveguide. So option C will be the right answer here. So here you can see option C, that is the shape of the waveguide, is the right answer. Then we'll go to the next question, 84. The velocity of propagation in a waveguide is, options are more than in free space, less than in free space, equal to free space velocity, none of this. So here the answer is option A, more than in free space. So the velocity of propagation in a waveguide is more as compared to the velocity of propagation in free space. Okay. So here you can see phase velocity. The phase velocity for a wave propagating within a rectangular waveguide is greater than that of electromagnetic radiation in unbounded space. That is means open. For example, the phase velocity of any propagating mode in a vacuum-filled waveguide is greater than c, where c is the speed of light in free space. So therefore, option A will be the right answer, more as compared to free space. So the velocity of propagation in a waveguide is more than in free space. Then we'll go to the next question, question number 85. So here the radar range is given by the equation. So there are four equations given. Now we have studied our radar range, and in that we have studied that radar range can also be given as radar range can be given as R is equal to C tau by 2, where C is the speed of light in meters per second, and tau is the round trip echo time. So it is round trip echo time, echo time in seconds. In seconds. So here tau can be replaced by delta t. So radar range R can be given as C tau upon 2, or it can be also written as C delta t upon 2. Okay. So here in these options, you can see option B is the right answer. It is C multiplied by delta t upon 2, where C is the speed of light and delta t you can take it as round trip echo time. Okay. So the option B will be the right answer here. So R is equal to C into delta t upon 2. Then we'll go to the next question. The satellite orbit is said to be dash if the direction of the satellite's revolution is the same as that of Earth's rotation. If the direction is same as that of Earth's rotation, then it is called as posigrade. So option D will be the right answer. Posigrade will be the right answer. So here we can see the concept direction of rotation around the Earth. There are two ways in which satellite orbit may be categorized. One is posigrade, what we have marked in the answer now. Posigrade says that the rotation around the Earth is said to be posigrade when it rotates in the same direction as the rotation of the Earth. Whereas retrograde says that the rotation around the Earth is said to be retrograde when it rotates in the opposite direction to the rotation of the Earth. So in this question, it was asked that when it rotates in the same direction as the rotation of the Earth. So it is posigrade. So here you can see option D, a posigrade is the right answer. The satellite orbit is said to be posigrade if the direction of the satellite's revolution is the same as that of Earth's rotation. Then we'll go to the next question, question number 87. GPS satellites circle the Earth dash a day. Now there are 24 GPS satellites which rotate around the Earth. Now they will circle the Earth twice, that is two times a day. So the option B will be the right answer here, two times a day. So here we can have the concept of GPS satellites. GPS satellites fly in medium Earth orbit, that is MEO, at an altitude of approximately 20,200 kilometer or 12,550 miles. Each satellite circles the Earth twice a day. This R24 slot arrangement ensures users can view at least four satellites from virtually any point on the planet, that is Earth. So, from any point on the Earth, you can at least view four satellites so that your GPS can give you the correct parameter. Okay, so at least four satellites are viewed at one point from any point on the Earth, and this is a given. This is done by those 24 satellites which circles the Earth twice a day. Okay, so here we can see the option B is the right answer, two times. That is, GPS satellites circle the Earth two times a day. Then we'll go to the next question, question number 88. Dash provides authentication and verify users' identity. This is a question from mobile communication. So here the options are ILR, where ILR means interworking location register, then EIR, which is equipment identity register, then AUC, which is authentication center, and IWF, which is interworking function. Now, out of these four, Dash provides authentication and verify user identity is AUC, that is authentication center. So option C is the right answer, AUC. So here you can see the authentication center AUC is a function to authenticate each SIM card that attempts to connect to the GSM core network, typically when the phone is powered on. Once the authentication is successful, the HLR, that is home location register, is allowed to manage the SIM and services. So it is AUC is the right answer. That is option C is the right answer. Then we'll go to the next question. The mobile station MS moves from one cell to another but stays within the control of the same base station controller BSC. Then handoff performed is called as what? Option A is intra-cell handoff. Option B is inter-cell intra-BSC handoff. Option C is inter-BSC intra-MSC handoff. And option D is inter-MSC handoff. So here we see the mobile station MS moves from one cell to another. That means it is inter-cell. So option B, that is inter-cell, and it stays within the control of the same base station. So that is intra-BSC. So option B, that is inter-cell intra-BSC handoff, is the right answer. So option B is the right answer here. Inter-cell intra-BSC handoff. Then we'll go to the next question. Microwave oven makes use of the following principle for heating the food. So in microwave oven, we know that microwave energy is used, which is given by magnetron to make the food hot. So for heating the food, and the process which is used for heating the food is called as dielectric heating. So option C is the right answer here, which is called as dielectric heating. So here, microwave oven makes the use of the following principle for heating the food, that is dielectric heating. Then we'll go to the next question. A QR code stands for. Okay. Now here options are a quality record code, quick response code, Coulomb recorder, and quiescent recorder. So from these options, option B is the right answer. That is quick response code. So QR means quick response. So as soon as you scan it, you get the complete data of what you have to do. So here, quick response code is the full form of QR code. So here you can see option B is the right answer, that is quick response code. Then we'll go to the next question, question number 92. A carbon microphone is a type of, options are velocity microphone, pressure microphone, temperature microphone, humidity microphone. So here whenever the sound energy, whatever we speak or whatever audio is there, whenever it hits the microphone diaphragm, so it is the pressure which will be converted into electrical energy. So here it is a pressure microphone. So the pressure is going to vibrate the diaphragm, and that vibration will be converted into electrical signal. So it is pressure microphone. So option B is the right answer. A carbon microphone is a pressure microphone. So here you can see option B, a pressure microphone, is the right answer. Then we'll go to question number 93. The dash uses mirrors to reflect the light in an image. Options are LCD, that is liquid crystal display projector. Option B is LED, that is light emitting diode or projector. Option C is DLP, that is a digital light processing projector. Option D is OHP, that is overhead projector. So these all projectors uses some or the other mirrors, but the specific answer which uses only mirrors is the DLP processor, that is digital light processing projector, which is specific in using mirrors. So option C we can give as a specific answer for this question. So it is DLP projector. So here you can see option C, DLP projector, that is digital light processing projector, uses mirrors to reflect the light in an image. Then we'll go to next question, question number 94. The closeness with which an instrument reading approaches the true value of the variable is. Now this is the definition what we have seen in EMI for accuracy. So accuracy is the closeness with which an instrument reading approaches the true value of the variable. So the error is less, the closeness is more. So if you're more close to the actual value, then your accuracy is more. So here option C, that is accuracy, will be the right answer. So option C, accuracy. Then we'll go to the next question, question number 95. A Wheatstone bridge is used for measurement of what? Wheatstone bridge is used for measurement of unknown resistance. So option A will be the right answer here, resistance. So Wheatstone bridge is used for measurement of unknown resistance. Then we'll go to the next question. A transducer that requires an auxiliary energy source for energy conversion. So to convert energy from one form to another, If a transducer is requiring auxiliary energy source, then that a transducer is a passive transducer. So a passive transducer is one which requires an auxiliary energy source for energy conversion from one form to another. Okay, so here option C will be the right answer, passive transducer. So here you can see passive transducer is one which requires an auxiliary energy source for energy conversion. Then we'll go to the next question. A transducer used for determining the type of P or N semiconductor. So a transducer which is used to find whether the semiconductor is P type or N type, which is that transducer. That a transducer is called as Hall effect type transducer. So Hall effect type transducer is one which can determine whether the semiconductor is P type or N type semiconductor. Okay. So here we can see the concept. Hall effect is an effect that is generally used to identify the type of semiconductor. When the Hall sensor is placed in a zone with a magnetic field and it is crossed by an electric current that is perpendicular to the field, a voltage difference, that is Hall voltage, appears in a directional orthogonal both to the magnetic field and the electric current, with a value that is proportional to the product of the magnetic field and the electric current amplitudes. The Hall voltage is an indicator. Remember here, the Hall voltage is an indicator of the semiconductor type doping, whether it is donor or acceptor, in the sense that it presents different signals for N-type semiconductor and a different signal for P-type semiconductor. That is why we can differentiate whether the semiconductor is N-type or P-type. So it is a Hall effect which is used. So here you can see option C, Hall effect type will be the right answer. Then we'll go to the next question. PMMC, that is permanent magnet moving coil meter, operates on the basis of principle of what? Alternator, AC meter, DC meter, or three-phase motor. So it is DC meter. So PMMC operates on the basis principle of DC meter. So here you can see option C, DC meter is the right answer. Then we'll go to the next question. A DC ammeter is constructed using. So we can have a DC ammeter, as we have studied. We can have a PMMC meter, and with the PMMC meter, if you are having a resistance in parallel, which is called as shunt resistance, then this can act as an ammeter. So this is PMMC and this is your shunt resistance. So this arrangement can act as a DC ammeter. DC ammeter. So here in this option, DC ammeter is constructed using option A is the right answer, a PMMC meter and a shunt resistor. So option A is the right answer, a PMMC meter and a shunt resistance, that is a resistance in parallel to the PMMC meter will give the arrangement of a DC ammeter. Then we'll go to the next question. Time-based generator in a CRO is used to generate dash type of voltage. So the wave which is generated, okay, is called a sawtooth wave. So sawtooth type of voltage is generated. The time-based generator in a CRO is used to generate sawtooth wave type of voltage. So option D is the right answer here, sawtooth wave. So here you can see option C, that is sawtooth wave is generated. Okay, so time-based generator in a CRO is used to generate sawtooth wave type of voltage. Okay, thank you, students.